Hi folks, this is the sampling distribution of the mean. So when dealing with sampling distribution, we convert the given units to standard units using the formula on the right. So this formula is used for these types of questions down here. So a random sample of 250 is selected from a population having a mean 30 and a standard deviation of 5. So if you pretend that this is a real life example, so it could be something like age or height or something like that. So just for example, think that the mean age of people in a whole country, maybe in all of Ireland, is 30, and that the standard deviation is 5. So then that's the average for the whole country. But if we were to pick a sample in of 250 people just out of it, so it's finding the probability that the mean of that sample is greater than 30.5. So, and it solves problems like this. So that's basically what it's used for. So if we're to put the numbers into the formula, so z equals, so x bar will be what we're kind of testing on anyway, so it's 30.5 in this case. So minus, and then mu will be the mean, so it's 30 all over, and then the standard deviation is 5, and we have to put that then over the square root of the sample size, which is 250 in this case. So if you put all that in the calculator together, it'll give you your Z score, and we get 1.58, so that's when it's rounded off. So that's our Z score. So if you look back at the questions, finding the probability that the sample mean is greater than, so we want to find the probability that Z is greater than 1.58. So therefore, if you think back to when you used the Z tables before, this is greater than, if you were to do it on a graph, we want the probability, so that's 0, 1.58 is about here. So we want to get this here, so what we have to do is, remember the Z scores will only, the Z tables will only figure it out for what's to the left hand side, so we have to do 1 minus whatever the probability, the Z score for 1.58. So if you look in the log tables, you look for 1.58, and it's going to be here. So it's 0.9429. And then we just have to take that away from 1 to get the probability. So that's 0.0571. So that's the probability then that, so look back at the question again. So if you know that the mean of the whole population is 30 and that the standard deviation is 5, well, if you just take a sample of 250 of them, the probability that the mean would be greater than 30.5 is just 0.0571. So if you're to convert that to a percentage, it's just 5.71%. So a small chance of it. So that's the first example. If you want to just pause the video and try this yourself, you can. Play it on and I'll go through the answer. So again, we're just putting in this formula, so it's x bar minus mu over standard deviation over root n. So a company installs new machines for packing peanuts. So the company claims that the machines will fill packets with a mean mass of 500 grams and a standard deviation of 18. So to test the company's claim, several samples of size 40 packets are taken and their mean masses are recorded. So find the probability that the mean of the distribution of x is less than 496. So again, if you were to think about all of the packets in the company, all have a mean mass, generally all have a mean mass of 500 grams. So that's the average for the company in general. So that's, but then you're just taking a sample of 40 packets. So you're taking, you're just looking at 40 packets and you're seeing what would the mean of those be. So what's the probability then that the mean of that distribution is less than 496? So 496 is what we're testing on, so that's that's our X bar, minus the mean is 5 all over standard deviation is 18 over 40 because it's 40 packets that we're testing. So you're just putting the number, it's easy enough to put the numbers in, but try and understand why you're putting them in and what you're actually testing for here, or you won't remember what to really do. So if you put that in the calculator then, so we get minus 1.41. So again, now because we have a minus here, so if it's a minus or if it's greater than, then you have to always do 1 minus when you're after looking at the Z table. So we're trying to find, it's finding the probability that the mean is less than, so we're finding the probability that Z is less than minus 1.41. Remember, you can't look at Z tables and do minus, so you have to do 1 minus the probability of Z being less than positive 1.41. So if you look up the tables for 1.41, and it's going to be here, so 9207. So it's 1 minus 0.9207. And you get 0.0793. So that's the probability then that, so it's a very small probability again, that the mean of the 40 packets would be less than 496. So remember that the mean of all of the packets in the company previously had been 500 grams. So that's it.